Hello, my name is Robert Neff, and we will be doing a demo for 3A, which is simplifying Boolean expressions through algebraic manipulation, including De Morgan's theorem. So I assigned myself this logic statement to work on. So we're going to go ahead and shift our focus to the right side of this logic statement. And the reason is because it has a prime outside of the parentheses. So we will be using De Morgan's theorem and distributing this prime across the inside of the parentheses. So as we do that, it'll actually change this sign from an or to an and. And as we distribute the prime here and here, there's already one present here and one that was present here. So they cancel each other out, leaving us with a AC and an A. Now our step 2 is actually going to be to combine them and leaving us with an AC. Now because of the commutative law, we can actually rearrange these, and that way we can locate similar literals. So right away we can see that A is the same, and using rule 7, which is a literal ANDed with a literal, is that literal. So we're actually going to be left with A and C. All right, we're going to shift our focus to the left side of this logic statement. Our first step is just making sure that there's no primes outside of our parentheses, and now that there's not, we can continue to our actual first step, which is the distributive law. So we're going to distribute B into the inside of these parentheses, leaving us with AB or CB. Now we can distribute further, leaving us with this large statement, A prime AB or A prime CB or ABB or CBB. Now using rule 8, which is a literal ANDed with that literal's complement is 0. We can use rule 7 for here and here, which is a literal ANDed with a literal is equal to that literal. So we can reduce it to 0 and B, or A prime CB or AB or CB. Now using rule 3 states that a literal ANDed with 0 is equal to 0. So we can go ahead and reduce this all together to 0. Now bringing them all down to this next step. So we want to go ahead and see if we can locate a new pattern. Right off the gate, we can see that CB is here and present, and CB is here and present. So I like to rearrange this to bring them a little close together so we can know what rule to use next. So BCA or BC, we can use rule 10, which states that a literal ORed with that same literal ANDed with anything else is equal to that same literal. So that means our literal is going to be BC and BC, and anything else will be A, leaving us with BC with the BC. Now we'll bring the 0 down here, but anything ORed with a 0 is that anything. So we can go ahead and just cancel the 0 out altogether, bringing everything down for our next step. So now we're combining our two sides together for our step 4, which is to distribute even further. Now using our distributive law, we will get BC AC or AB AC. Now using the commutative law, we will go ahead and rearrange these to pair up the literals together. So right away we'll see C and C and A and A. Now anything using rule 7 again, a literal ANDed with a literal is that literal. So we'll go ahead and end up with ABC or ABC. Now, any literal or with that literal is that literal. So we finish out with our final answer, ABC. Thank you.